Hey, what's up guys? This video is for section 8.8, which is factoring difference of squares. So let's get to the video here. In the top, you guys can see the definition of a difference of squares. So we do have an a squared minus a b squared equals, and when you factor that difference of squares, and it is called the difference of squares because there's a difference in the middle, which is minus, and the two terms are perfect squared terms. And we'll talk about the perfect square numbers in a second. But when you guys factor this, a squared minus b squared, you guys will get a minus b times a plus b. Now, remember, factoring is what you can find that will multiply to get that polynomial back. So if you multiply these two right here, you guys will get this back. If not sure, I'm going to show you guys here in the video. When you multiply, you will get that polynomial back. So we multiply, we distribute a times a, and that's going to be a squared. We multiply a times b, that's going to be positive ab, and then you multiply negative b times a, that's a minus ab. You put the letters, the variables in order, alphabetical order, and you multiply negative b times positive b, and we get negative b squared. So negative b times a positive b, remember that you have to add the exponents, and it is a negative b squared. Now if you look at the ones in the middle, the terms positive ab minus ab, they do cancel, and we get the a squared minus the b squared. So eventually you get that polynomial back. Now how do you actually factor that difference of squares? Well, the two terms are going to be perfect square terms where you can use the square root to find the factors, or the two polynomials, the two binomials that will multiply to that. So this is what I mean. If you guys have, for example here, x squared minus 25, remember the x squared has an invisible 1 in front of the x, so there's a 1 there. Those two terms, the 1 x squared and the 25, kind of ignore the minus for now. I'll explain the minus in a second. But the two terms, they are perfect square numbers. So how do you know they're perfect square numbers? That's the list I have down here. And these are just some of the perfect square numbers that we have. There's more, infinite more numbers. But if you know how to identify those numbers, you are going to use the square root of the numbers. So 25 is a perfect square numbers right here. The square root of 25 is 5. 1 is a perfect square numbers right here. The square root of 1 is 1. So every time you guys have those perfect square numbers in your binomial, so any of these numbers here, you can use the square root of that number. So remember, just look for those specific numbers, and if you guys have a calculator, you can use it to find the square root. But in order to be a difference of squares, there's two things you have to look for. Number one, you must have a difference, a minus in the middle. Number two, you must have perfect square terms. So this number here, this term, and this one here, you guys will take, they have to be perfect square numbers. How do you get the answer? Well, you are going to set up your two parentheses. You are going to take the square root of the first term. So the square root of 1 is 1 and 1. And x squared, when you take the square root of x squared, that's going to be just an x. And that's because, guys, when you have the square root of an x squared, remember that the square root is the second root that you're looking for. So you can have a little 2 outside of the radical right there. That represents a square root. And when you guys have the square root of a squared, well, they're actually opposites of each other. So what happens is they do cancel each other, the square root and the square, because they're opposites. Just like a negative 7 and a positive 7. They're opposite of each other. They cancel each other. So same thing with the square root and a squared, the power of 2, they cancel. So all you have left is the x. So when you guys take the square root of 1, that's 1. So you put a 1 here, 1 here. The square root of x squared, that's x. So you put an x here, x over here. For the minus, remember that difference of squares, you must have a negative in the middle. You must put a minus and a plus inside of your two binomials. So they have to be different signs. And then you guys will take the square root of 25, and the square root of 25 is 5. It's 5, so you put 5, 5 here. And that's your answer, x minus 5 times x plus 5. This is going to multiply to that binomial, x squared minus 25. Another example here is the same thing. 25m squared minus 64. Well, 25 is a perfect square number. 64 is a perfect square number, and we have a minus in the middle, difference of squares. So you guys will factor by using the square root of 25, which is 5, m squared. Remember, the square root of m squared is m. You put an m, so 5m. Different signs, minus and plus, and the square root of 64, 8 and 8. And that's your answer right here. So you guys don't have to use the method I showed you guys in the previous videos where you multiply a times c, because these are different. These are special. This is one of the special cases where you have difference of squares. There's another special case I'm going to show you guys on my next section, on my next video. But this is one, and make sure you know how to identify those perfect square numbers. Right, so let's try some examples here. We want to factor all these difference of squares, these binomials here. So I'm going to look at the first one, x squared minus 16, and I am going to start with my two binomials. I'm going to look for the perfect square numbers, so I put the two binomials here. I know the x squared has an invisible 1 right there. I know 16 is a perfect square number because the square root of 16 is 4. So it is a perfect square number. This number, 1, is a perfect square number. So I am going to use the square root of 1, x squared. Remember, you guys put a 1x and a 1x right here. You guys don't need that 1 next to the x, so I'm just going to erase that 1 next to the x. And then you guys go to the next term. The next term is 16. The square root of 16 is a 4 here and a 4 over here. And for your signs, remember, you are going to use a minus and 1 and a positive on the next one. And that's it. That is your answer. If you guys multiply those two, x minus 4 times x plus 4, you will get x squared minus 16. The middle terms will cancel. Now, if you guys have a binomial where the r is the second term and it's a difference of squares, don't try to move the r and put it in standard form. You don't have to in this case, because when you have a difference of squares, that's a special case. So you can leave the r at the end of the binomial. So we have 81 minus r squared. That's fine. Do not move this one to the front. You do that when you have a trinomial. If you have 3 terms, make sure you guys have standard form. But here, it's okay, difference of squares. 81 is a perfect square number because the square root of 81 is 9. So I am going to set up my two binomials here, and I'm going to start with the first term, the square root of 81. That's 9. I'm going to take the square root of r squared, and remember it has a 1 here, so that's going to be 1. The square root of 1 is 1. R, I don't need that 1 next to the r, so I'm going to put an r, and we need a minus and a plus. So the answer for this one here is 9 minus r times 9 plus r. Even though the r is in the second space, it's at the end of the binomial, that's okay. It's a special case, difference of squares. So you guys can leave it and just use the square root of the perfect square numbers. Alright, so let's try this one here. 9x squared minus 49. 9 is a perfect square number. 49 is a perfect square number. They do have a perfect square root. So I'm going to use the square root of 9 right here, which is 3. And the square root of x squared is x. 3x. I'm going to set up my signs, minus and a plus. And the square root of 49 will be 7 and 7. So you guys would get 3x minus 7 times 3x plus 7. Now this one, you guys notice that we have a 25 perfect square number, p squared plus 49 perfect square number. Now let me tell you guys with the plus in the middle. If that happens when you have perfect square numbers, but you have a plus in the middle, then this is not a special case. It's not a difference of squares. So you are not going to set it up with the answers with the plus and the minus because it's not going to work. And I'm just going to show you guys that it doesn't work. I'm going to put here the two parentheses. I know the square root of 25 is 5, and then p squared becomes a p, 5 and a p. The square root of 49 is 7. But if you put a minus and a plus, right away, guys, right away, when I multiply this term, negative 7 times a positive 7, that's a negative 49. We don't have a negative 49. We have a positive 49. Now, some people, they think that, well, how about if you change this to a plus? Well, let me show you that you're not going to get the same binomial. If you start distributing, you multiply 5p times 5p, you do get the 25p squared. But when you multiply 5p times 7, that's going to be positive 35p. And if you multiply 7, positive 7 times 5p, that's positive 35p. And positive 7 times positive 7, that's positive 49. Look at the middle. 35 plus 35, that's going to be 70. So we get 25p squared plus 70p plus 49. So we do get the plus 49 here. You get the plus 49, but we got an extra term that we don't have. That's 70p. So we don't have the middle term. So this one doesn't work. This is not your answer. So I'm going to cross it out because it doesn't work. And when this happens, this binomial is prime. And that happens, guys, when the numbers are not perfect square numbers, even though if you guys have, let's say, a minus in the middle, but this number is 47, not 49. 47 is not a perfect square number. So you're going to say prime. It's not a difference of squares. If you guys have a plus in the middle, you guys will say prime. It's not a difference of squares. Even though the numbers are perfect square numbers, you might have a 16 and you might have a 64 over here, but plus in the middle doesn't work. It's going to be prime. All right, so let's try when you have two different variables. Same idea, same concept. I am looking at the numbers, the terms 16 and 9, those are perfect square numbers. There's a minus in the middle, so we do have a difference of squares. I am going to make my two binomials here, and I'm going to take the square root of 16h squared. That's going to be a 4h and a 4h. I'm going to take the square root of 9 with the a squared. So the square root of 9 is 3, and I'm going to put an a and 3 and an a. When you multiply, guys, make sure that you get that 9a squared. 3a times 3a, that's going to be 9a squared. 4h times 4h, that's going to be 16h squared. I need my signs, one negative, one positive, and we got the answer. That's all you do, guys. Difference of squares, we use the square root. Now this one here is different because the exponent is not 2. The exponent is 4. Now, it also works, guys, if you guys have an exponent of 4 and your numbers are perfect square numbers. So I'm looking at the 100. That is a perfect square number. So we can actually factor by using the difference of two squares. But we are going to have the exponents a little bit different on these two binomials. So if you think about it, guys, when you take the square root, here's an invisible 1, the square root of 1b to the 4th power, we know the square root of 1 is 1, but when you guys break down, you take the square root of b to the 4th power, that's going to be a b squared and a b squared, because when you multiply a b squared times a b squared, you guys will get a b to the 4th power. So it works. So you use a square. Now, for the 100, well, the square root of 100, that's 10. So you put a 10 here, 10 over here, minus and a plus. Now, here's a tip for you guys when you are factoring. If you see a square, you see a variable x, y, b, m, whatever variable with the square, check if you can factor even more. Because sometimes you guys can factor those binomials with the square. So I'm looking at the b squared. Okay, maybe I can factor. There's a minus, difference of two squares, but the 10 is not a perfect square number. So in this case, you guys cannot factor this binomial. And it's always a good idea to check. Now this one over here, b squared plus 10, well, we have a plus in the middle. So right away, we do know that you cannot factor that binomial. So that's my answer here. But I want you guys to always check if you can factor even more when you guys have a difference of squares. So this one, same thing. You are going to factor by using the two binomials here. I am going to take the square root of 16x to the 4th power. So the square root of 16 is 4. And I'm going to use an x squared, 4x squared, because when you multiply 4x squared times 4x squared, that's going to be 16x to the 4th power. You add the exponents because you have the same base, you multiply. When you multiply, you add the exponents. Now the square root of 81, that's going to be 9, and I put a 9. I put a minus and I put a plus here. I want you guys to look at this binomial because we can factor this one. Why? Well, the 4 and the 9 are perfect square numbers, and there's a minus in the middle, difference of two squares. So I can factor this one even more. I'm going to keep going. I'm going to do an extra step to factor. I'm going to set up my two parentheses again. The square root of 4 is going to be 2x. The square root of x squared is x. 2x. The square root of 9 is 3. 3. We need a minus. We need a plus. This one here, the 4x squared plus the 9, even though the 4 and the 9 are perfect square numbers, we have a plus. Remember? Nope, you guys cannot factor that one. So we leave it as 4x squared plus 9. So my answer is all this. And the last thing I'm going to talk about, guys, is when you have a greatest common factor that you guys can actually factor out, and then you guys use the difference of squares to factor. So that's one of the things you always have to look for. If you can factor out a GCF, you have to factor out that GCF. So this one here, I'm going to use one parenthesis, but because I can factor out a 10, that's the greatest common factor for 10 and 40. 2 is a common factor. 5 is a common factor, but 10 is the biggest one. 10 goes into 10 and 40. And I can also factor out an x. So when you guys factor out the 10x, we are going to have a 1x squared, because you guys had x cubed, but you took out an x, so that's going to be an x squared left, minus 40 divided by 10, that's going to be 4, and you guys took out the x, so no more x's. So we got the 10x outside. Now look at this binomial, x squared minus 4. Difference of squares, because we do have an invisible 1 right here, so that's a perfect square number. 4 is a perfect square number, so we can factor. So I'm going to put my two parentheses right here. I'm going to use the square root of 1x squared, that's 1x, x right here, the square root of 4, 2, you put a 2, minus and a plus, and then you guys bring down the 10x, the one you guys factor out. So that's my answer. So remember that if you guys can factor out a GCF, you have to factor that out first, and then you guys might have a difference of squares. Doesn't happen all the time, but sometimes you do have one. So let's look at this one here. You guys will have to factor out, I'm looking at the greatest common factor, 7 and a k. 7 goes into 28 and k, and the k is for both of the terms. So 28 divided by 7, that's going to be 4k squared. Remember, you took 1k out, minus 7 divided by 7 is 1, and then you guys took out the k. 4 and 1 are perfect square numbers, and you guys have a minus in the middle. So you guys can factor that one out. I'm going to put my two parentheses here. The square root of 4k squared, that's 2k, 2k. The square root of 1 is 1. Put a 1, minus and a plus, and then you guys bring down the 7k. So my answer are all those factors there. Now this one, guys, is a little bit tricky, because if you notice, the 36 and the 16, those are perfect square numbers already. And they both have a k to the fourth and k to the squared. So right away, I notice that I can take out a k, so I'm going to take out a k here, and the lowest exponent for the k's, I'm looking at the 4 and the 2, 2 is the lowest one. So I need to factor out a k squared. You always factor out the variable with the lowest exponent. Now let's go back to the 36 and the 16. Yes, they are perfect square numbers. The square root of 36 is 6, the square root of 16 is 4. But guess what, guys? They do have a common factor, and the greatest common factor is 4. So if you guys can factor out one GCF, you have to, guys. So this one, even though they're perfect square numbers, I have to factor out a 4. And you always want to use the biggest number. 2 goes into 36 and 16, but that's not the greatest number. 4 is the greatest number. So when you factor out the 4, you guys will divide 36 by 4. That's going to be 9k squared, because you took out 2 from 4, so there's k squared, minus 16 divided by 4 is 4, and then you guys took out the k squared. Well, guess what, guys? 9 and 4 are also perfect square numbers. So even though you took out the 4, k squared, you still have a difference of 2 squares. So let's go ahead and factor that difference of 2 squares. I'm going to have my two parentheses here. I'm going to take out, I'm going to use the square root of 9k squared. That's 3k over here. I'm going to take the square root of 4. That's 2 here. You put a minus and a plus, and you bring down the 4k squared. So my answer is right here. And I want you guys to be careful with those tricky questions, because even though it looks like you have perfect square numbers, you can still factor out a GCF. So make sure you guys do that. Check, double check, triple check if you have to. And if you have a GCF, factor that number, variable, whatever term out first, and then you guys factor the difference of squares. Alright guys, this concludes my first video. I'm going to do a second part for this section. So if you guys like my videos, make sure you guys click on the like button, and you guys can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.